Okay, so today we're looking at something called BitVM, and it comes with a huge claim that you can compute, well, anything you want on Bitcoin. Now, for a blockchain that's famous for being super simple and secure, that sounds kind of impossible, right? So how does it work? Let's dive in and break it all down.
So let's just jump right in with a question. Could you play a full game of chess on Bitcoin? I mean, right now, today. The answer is a big fat no. It's just not going to happen. Chess has all this complex logic, rules, keeping track of the board, and Bitcoin's basic scripting language, it just wasn't designed for any of that. But what if I told you there might be a way to do it without changing a single thing about Bitcoin's core code?
All right, so to really get why BitVM is such a breakthrough, we first have to understand what Bitcoin can't do. See, its smart contract abilities are super limited, and that's on purpose. It's not a bug, it's a feature. The whole point was to make it as secure and as stable as possible.
The network really only gets a handful of things. It can check signatures, that's how you prove you own your Bitcoin. It understands time locks, which is all about when a transaction can be spent. And it has hash locks, which are kind of like little digital puzzles. You need the secret password to get the funds. And don't get me wrong, these are powerful tools, but they're not the right tools for building something complex like a chess game right on the blockchain.
And this is where BitVM just completely changes the game. It's a totally new way of thinking that could let us do these incredibly complex things. And the craziest part? It doesn't require any changes to Bitcoin itself. None.
Okay, so here's the absolute core idea you need to get. With BitVM, all the hard work, all the actual computing, it happens somewhere else, off-chain. The Bitcoin network itself, it only gets involved if there's a fight. It's like a judge. It doesn't run the program for you. It just steps in to verify a tiny little piece of evidence that proves someone cheated. That's it. And this really shows you the massive difference. Doing everything on-chain like other platforms do, it's slow, it's expensive, and it totally clogs up the network. But BitVM's approach, on-chain verification, it's the complete opposite. It's fast, it's cheap, and the footprint on the blockchain is tiny. Why? Because most of the time, nothing even happens on-chain. If you're familiar with optimistic rollups, this is going to sound very, very familiar.
So the whole thing is basically set up like a game between two people. You've got the prover, and they're the one making a claim. They're saying, hey, I ran this program, and here's the answer. Then you've got the verifier, and their only job, literally their only job, is to double-check the prover's work and call them out if they're lying.
Okay, so how on earth does this actually work? I mean, how do you build something this complicated using Bitcoin's simple little pieces? Well, it all starts with one tiny fundamental building block. Think of it like a single digital Lego brick. And that little building block is called a bit value commitment. It's basically a really clever crypto trick. It lets the prover lock in their choice for a single bit of data. Is it a 0 or is it a 1? They have to commit, put it in a vault, and they can't go back and change their mind later without everyone knowing. And hey, this isn't some far-off theory. Check this out. This is a real, actual Bitcoin script that you can use right now. So the way it works is, the prover makes up two secrets. One stands for 0, and the other stands for 1. To make their commitment, they have to reveal one of those secrets. And just keep this in the back of your mind, because revealing both of them, well, that's the fatal mistake that's going to cost them everything. Okay, so now you take those little bit Legos and you start snapping them together. When you combine a few, you can build a logic gate commitment. And this is where things get really, really powerful. And this is a fundamental concept in computer science, any program in the world can be boiled down to a bunch of simple logic gates, like a NAND gate. So if you can build one of those, you can pretty much build anything. So what you're looking at here is the script for just one of those logic gates, a NAND gate. Think of it as one tiny piece in a giant puzzle. This script forces the prover to show their work. They have to reveal the values for the inputs, A and B, and the output, C. And the Bitcoin script itself is the referee, checking the math to make sure that C really does equal A NAND B.
All right, now you just scale that up, way, way up. You take thousands or millions or even billions of these little logic gates, and you wire them all together into a massive circuit that is your program. And here's the magic trick. Thanks to an upgrade called Taproot, you can bundle all of this entire computational blueprint, into a single, normal-looking Bitcoin address. It's tiny on the outside, but inside, it contains the instructions for literally any program you can dream up.
Okay, so we've got the digital Legos, we know how to build the thing, but wait a minute. What stops the prover from just lying about the result, right? This is where we get to the most important part of the whole system, the high-stakes game that keeps everybody honest. Now, this is absolutely crucial to remember. In the happy past, where everyone plays nice and tells the truth, nothing ever touches the Bitcoin blockchain. It all happens off-chain. This whole complicated on-chain game we're about to walk through, think of it as the nuclear option. It only gets used when the verifier thinks someone is cheating. Okay, I know, this diagram looks a little intense, but the idea behind it is actually pretty simple. Let's say we have Vicky the verifier and Paul the prover. Before they even start, they pre-sign a whole bunch of transactions. It's like they're setting up all the possible moves in a game ahead of time. So if Vicky thinks Paul is cheating, all she has to do is broadcast one of these pre-signed transactions. That's the challenge. It forces Paul to come on chain and prove his work for one specific step. Vicky can just keep doing this, zeroing in on the problem until she finds the exact spot, the one single logic gate where Paul's math doesn't add up. So what's Vicky really looking for? What's the smoking gun? She's hunting for something called equivocation. This is the one big, unforgivable sin in this system. It's when the prover gets caught saying two different things at once, claiming that the same variable is a 0 over here but a 1 over there. It's a flat-out contradiction, and it's proof of fraud. And this is the payoff. Remember how we said the prover has two secrets for every single bit, one for 0 and one for 1? Well, if they equivocate, if they lie, they'll be forced to reveal both secrets for that one bit. And once the verifier has both of those secrets, it's game over. She can show them both to the Bitcoin script, which is like showing a signed confession to a judge. It's undeniable proof of cheating, and she gets to take the prover's entire security deposit. The financial reason to just tell the truth is massive.
So, okay, the tech is obviously super cool and clever, but let's zoom out for a second. What does something like this really mean for Bitcoin's future?
Honestly, the potential here is kind of mind-blowing. You could build much safer bridges to move Bitcoin to other chains. You could have things like prediction markets. You could even test out new features for Bitcoin itself before they get added to the network. And yeah, you could finally play a real, verifiable game of chess or Go or poker where Bitcoin is the final, incorruptible referee. Now, let's be real for a moment. This is still very early. The current version of BitVM has some big limitations. Right now, it's really just for two people. It needs a ton of back and forth communication off-chain, and getting it all set up is pretty complicated. But the research is already pointing towards what's next, getting more people involved, making the circuits way more efficient, and maybe even plugging this whole thing into the Lightning Network. The paper itself ends with this really powerful statement. For years, people have argued about whether Bitcoin is Turing-complete, which is just a fancy way of asking, is it a universal computer? And what BitVM suggests is, yeah, it is, but in a very Bitcoiny way. Not because it runs any program you throw at it, but because it can verify the outcome of any program. And so, that leaves us with this one giant question to think about. If any computation, literally any computation, can now be checked and verified by the most secure computer network on the planet, what are we going to build next? The design space just exploded.